Hey there, welcome back to my channel. So this is your Ramandeep Singh, and we are continuing in the graph series. We were learning about how to solve problems related to graphs and trees. And in this particular video lecture, we'll be solving a problem, the next LeetCode problem, which is very similar to the previous, which is very similar to the problems which we solved in the last couple of videos. So I could not upload videos for the last week, for the last couple of weeks, just because I was busy with some work, and so from today onwards, I will be consistent in my content creation, and I will be posting one video every single day from today onwards. I'll try to do this without breaking the streak. And so today in this session, the problem which we will be solving will be this maximal network rank. Okay, so this problem is a medium problem over the lead code, and very similar to the problem which we solved in the last couple of videos. In the last couple of videos we learned about in degree, how to count in degree of a node, how to count out degree of a node, and what is the in degree out degree, how to perform breadth first search, depth first search. So this problem will involve all those concepts which we learned, specifically the out degree and in degree concepts. Okay, so let's jump to the problem statement without wasting any time. Hello, hi everyone, welcome back. So let's move to the problem statement. We'll solving this problem today, and the problem name is maximal network rank. Okay, maximal network rank. So let's read the problem statement. So there is an infrastructure of n cities with some number of roads connecting these cities. Each road I, is a pair AI comma BI, indicates that there is a bidirectional road between cities AI and BI. Okay. The network rank of two different cities is defined as the total number of directly connected roads to either city. If a road is directly connected to both cities, it is only counted one. So what does that mean? What is the network rank of two different cities is defined as the total number of directly connected roads to either city. मतलब या तो city first को या फिर city second को. So for instance, let's say here we have, let's say, city number 0 and city number 1. Now what is the network city, what is the network rank of two different cities, city number 0 and city number 1? It's the total number of directly connected roads to either of two cities, 0 or 1. So how many roads are connected to 0? 2. How many roads are connected to 1? 2. Remember, 0 1 is not counted. The road between 0 1 is only counted once. So okay, sorry. So how many roads are connected to 0? 2. How many roads are connected to 1? 2. So the total the network rank of two cities 0 and 1 will be 4. Cool. What will be the network rank of city 1 and 2? It would be, how many roads are connected to 2? 1. How many roads are connected to 1? 2. Remember, I am counting this road which connects these two cities exactly once. So the network rank for the city 1 and 2 would be 3. What is the network rank for city 3? 3 and 1. It would be, how many roads connects 1? 2. How many roads connects 3? 2. So it would be 4. What would be for 0 and 3? It would be, how many connects 0? 2. How many connects 3? 1. So it would be 2 plus 1, 3. So that's what we have to do. So here in this case, the maximum of all these pairs will be my answer, and the maximum here I can see is for city 0 and 1, and it is 4. Maximum maximal network rank is for city 0 and 1. Also maximal network rank is also for city, I can say, yeah, this is the only one. This is the only answer for this. For example 2. So let's take this example. So this is what we have to do. We have been given an integer n and this type of connected cities or a graph. We have to return that maximal network rank of entire infrastructure that we have been given. Okay. So let's understand this with an example. Now here we can see that this is a bidirectional roads, means there are bidirectional edges between the nodes. Okay. So let's draw this second graph over the board. 0 1 2 and then we have 3 4 3 का है, yes ठीक है, and then from 2 to 3 we have an edge, ठीक है, ये हो गया, and then from here to here we have this, ठीक है, cool है. Now I can see what's the network city rank for 0 and 1. 1 2 2 edges plus for 1 1 2 2 edges, it's 4. So for 0 1 the network city rank is 4. For 1 and 2 how many connects 1 1 2 3, how many connects to 1 2, so for 1 2 it's 5. For 2 and 4 what is it, for 2 I can say 1 2 3, for 4 it's 0, so 3. For 3 and 4 how many, for 3 and 4, for 3 1 2 3, for 4 it's 1, so 4. For 1 and 3 3 connects 1, and for 3 it's 2, because this edge has to be counted exactly 1, and I have counted it with 1. For 1 how many roads connects it, 1 2 3. For 3 how many connects it, 1 and 2. This is counted exactly 1, not twice, so it would be 2 plus 3 5. So for 0 and 3, for 3 1 2 3, for 0 it's 1 4 1 2 3 1, this is counted exactly once. So I can see that the answer is 5 for this pair and for this pair, so 5 would be my answer. That's my maximal network rank, ठीक है, cool है, and that's all for this one. And how gonna solve this problem? So the solution is simple. It becomes obvious if you are a little bit experienced in these type of problems. If you see, all we have to do is to just count the degrees. So count that's all. You have to count the degrees, है ना, you have to count the degrees, and that would be my answer, ठीक है. What type of degrees? In degrees. Why? Because like we can see that if I am, let's say if I am creating an edge between 0 and 1, this edge, then for 0 1 degree increase, and for 1 1 degree increase. So I will simply use a single array to update the degrees. I don't need to use two arrays, just you can use a single array to count just how many roads connects a particular node. There is no concept of out and in here, because all we have to do is to just count how many edges are there connected to a particular node, okay. So like I took an example of 0 and 1 here. So once you count the degrees, all you have to do is to check for the right pair of nodes. How can you check for that? One simple thing which comes to our mind is to find the node with the maximal degree, then plus node with second maximal degree. So this can be a trap for you. If you are thinking like this, it may give you a wrong answer, because because there is a common edge is involved. So common edge, so let's say this has a certain degree, let's say x, node number 1. This node number 2 has a certain degree, let's say y. So x plus y minus this has to be subtracted. This has to be subtracted. Why? Because while counting x, I have counted this edge. While counting y, I have counted this. I have counted this edge. So this edge has to be subtracted once. So because of this property, I cannot directly find the max and second max and simply add their degrees. No, not the case. Why? Because there can be a graph. So let's think of it: 1, 0, 2, 3, 4, and let's say this, and now you have this. Was that the graph? ठीक है, 4 है. Yeah, so here I can see that if I find the node with the max degree, it would be 2, because this has a degree of 3. And then what's the node with the second max? It can be 4, it can be 3, it can be 0 as well, it can be 1. But which one is the right? Which one is the right? If I choose 2, if I choose 3, then what will be the maximal network rank? For 2, the degrees is 3, for 3 it's 2, and then I'll have to subtract this as well. So it would give me 4. If I take 4 as the second max node, then it would be again 3 plus 2 minus 1. I'll have to subtract this edge, 4. If I take 0, 3 plus 0, then I'll again have to subtract this edge. But now if I take 1, 3 and 1, 2 and 1, then the answer would be a little bit different. I don't have to subtract anything because there is no common edge between 1 and 2. So the answer would be 5. So that's the reason I cannot simply find the max and second max, because I am not sure which second max I am landing to. I can't label because this also has degree 2, this also has degree 2. So how can I differentiate between 1 and 3? There is no way. Like, not a simple or naive way to differentiate between these two particular type of nodes. So that's why that solution will not work for this, and I also thought the same solution when I first saw this problem, but it will not work. Okay, so all you have to do is to, how many nodes are there, how many nodes are there? I can see there are only 100 nodes, so just perform brute force, n square. So all you have to do is to just iterate for I is equals to 0, I less than n, I plus plus, then inside it for j is equals to I plus 1, j less than n, j plus plus. Answer would be max of answer, comma, degree I plus minus ठीक है. So finally you will print answer. So that's your answer. That's all you have to do. Baqaida, you have also like counted the degrees. So for edge, in edges, degree h0 plus plus degree h1 plus plus. This has to be built. Also you will also have to create that adjacency matrix, this. So that's why we are creating this. What does that says? This adjacency matrix I'll have to create in order to account for these edges. So if let's say I'm taking any pair, I'm taking 0 and 3, then if there is an edge, so I simply add this degree of this, so degree of 0 plus degree of 3, and if there is an edge between 0 and 3, then I'll have to subtract it once. So in the adjacency matrix of the graph, I will have this edge present, 0 and 3, so I will subtract it from there. Okay, so that's all. Adjacency is equals to 1, and also adjacency h1 is equals to 1. Okay, so that's the solution, and I hope you learned something out of it. Let's jump to the code implementation part. So first let's create a degree matrix, a degree array, new int n. Then we will have this another array which is adjacency list. Then we will iterate over these roads. Okay, and simply build this degree h0 plus plus degree h1 plus plus. Then we have adjacency of h0 h1 1 ठीक है, cool है. Once we are out of it, what we're going to be doing is we're going to be iterating for what? We'll be iterating किस पर iterate करना है अब? Iterate over all the nodes 0 से n. j I plus 1 j less than n j plus. Then what after that? Yeah, max of result comma what, degree I plus degree j minus adjacency of I j. ठीक है, got accepted. And let's see if it works. Yeah, it got accepted. So that was all. It was a simple brute force solution. We just had to figure out that why that solution of first max and second max will not work, and that's all we had to figure out in this problem. And I will see you soon in the next one, and we will try to solve harder level problems as well in the upcoming videos. And that's all for this one. I hope to see you all in my next one. Till then, bye bye, ladies and gentlemen. So that's all for this video, and so today I was like on full meditation from the morning, and I solved exactly one lead code problem, and now I will be moving back to the meditation. Now I also have a really deep interest in spirituality. So if you want some good spiritual lessons, then you can please contact me. I will put my contacts down in the description. You can always reach out to me anytime, 24 hours, okay? And I will give you some good lessons on spirituality. So that's all for this one. I will see you in the next one. Bye bye.